Hello everyone, welcome to A+BI. This channel is all about complex numbers, and in this video we're going to be solving a really cool equation with complex numbers. Are you ready? Alright, let's get started. We have the absolute value of z squared minus 2 times the real part of iz, I'll explain what that means, equals 3. So we're going to be solving for z values. Z is a complex number. If you're new to complex numbers, go ahead and check out my lecture videos. If you like algebra, number theory, and trigonometry problems, go ahead and check out Cyber Math. That's my other channel, my very first channel. Great, so let's go ahead and take a look at this problem. Now, if we did have something like this, let me just show you real quick. This would be really cool. You know why? Because we could add 1 to both sides and complete the square. Completing the square is fun, don't you think? And we could definitely use it, but that's not what we have. But is there any relationship between the real part of iz and the absolute value of z? Any type of association? What is the real part of iz, right? I mean, what is that supposed to mean? Let's look at some examples, shall we? For example, if z is equal to 3 plus 4i, iz would be just multiply this by I and use the distributive property, right? If you distribute, you're going to get 3i plus 4i squared. Let me not forget that. Let me not forget to tell you. I squared is -1 because I is the square root of -1 in the complex word. That is the most important thing, the imaginary unit. So this becomes -1 and this becomes -4 plus 3i. So when you multiply a complex number by I, the real and imaginary parts seem to switch. They do. And then the real part is negated. That's interesting. Why is that happening? So you can think of it this way too. Kind of like a rotation, which is fun, right? You have a number. You multiply by I, which is kind of like a vector, right? But when you multiply by I, it's basically giving it a 90-degree rotation, okay? Because when you multiply two complex numbers in polar form, you add their arguments, which is the angles. So you kind of get something like this. Notice that the real and imaginary parts are switched, but not only that, the real part is also negated because it's positive here and negative here. Of course, depending on your coordinate or quadrant, you may get different results, but this is always going to work, okay? But that's not what we have, so we can't really take advantage of that. So we kind of have to look at this separately. So let's go ahead and rewrite the problem. How can I solve this if I can't use completing the square? Don't worry, there's still a way to do it. Now, one thing to always keep in mind, that's why I named this channel, what did I name this channel? A+BI. Yes, of course, right? Hopefully you knew that. So A+BI is the name of this channel because A+BI is a complex number. So you can write any complex number in this form, which is called the standard form. So A+BI is a complex number, but guess what? A and B have to be real numbers. You know, you gotta just pay attention to that piece. So since A+BI is a complex number, then I can replace z with that everywhere, right? Can't I? I mean, I should be able to normally. Now, notice that we have the real part in this equation. We don't have the conjugates. What do I mean by conjugates? Let me go ahead and talk about that real quick. So if z equals A+BI, which is a general complex number form, then the complex conjugate, which is z bar with a little line over the z, is A minus BI. So what's so special about a complex conjugate? Well, if you take these two things and add them, the imaginary parts cancel out and you get a real number. What if you multiply them? Again, you get something like this, which is another real number. So if you take a complex number and its complex conjugate, add them or multiply them, you always get a real number. In that sense, the complex conjugate is unique. But why did I say that? So suppose you had a problem like this. I'm giving you some different cases so that, you know, when you see a problem, you kind of know what to do. It's important to understand, you know, how this works. So for example, suppose you had a problem like this. I'm not exactly sure if this is going to work, but I'll just make up some problem. I don't know, maybe 3 plus 4i. Because the right-hand side is probably going to be a non-real complex number, okay? Now, in this case, we could do one thing. We can conjugate both sides. What does that mean? Well, you can take By the way, one thing to keep in mind, if you take the absolute value squared or just the absolute value itself and conjugate it, you're still going to get the same thing. Why? Because the conjugate of A is A. It's a real number. There's no imaginary part, so there's nothing to change. Make sense? So one thing you can do when you have a problem with complex conjugates is you can conjugate both sides, and that'll give you another equation. Then you can solve it as a system. What do I mean by that? This is going to stay the same. This is going to be Z. And now if you conjugate this, you're going to get 3 minus 4i. Now I have Z and Z bar. That doesn't look like a good idea. I could probably subtract and get rid of this. But anyways, you get the idea. This didn't work well, but we're going to go back to our problem because our problem is different. How is that different? It has absolute value. It has the real part, but it doesn't have the conjugate. Okay, great. That's fine. Let's go ahead and rewrite it one more time. Just keep writing the problem so you kind of get used to it. This is the original problem. I'm going to try to solve for Z. And the key is using this. Z, replace Z with A plus BI. So what is the absolute value of Z? The absolute value of Z is going to be the square root of A squared plus B squared. And notice that that is the square root of the product of the complex conjugates. Again, I go over all these in lecture notes. Go ahead and check them out. Or did I say lecture notes? I meant lecture videos. All right, great. So now let's go ahead and square this. And then real part of I times, what was Z? A plus BI. So I'm going to go ahead and multiply this and then look at the real part because I don't know what it's going to look like, right? There's no formula that turns the real part of IZ into something. Wait a minute. There is actually a formula. Remember what I told you, when you multiply a complex number by I, you give it a 90-degree rotation, I can't say that, rotation, and that negates the real part. But the real part is the imaginary part. Wait a minute, this is too confusing. Let's just do it with symbols. Okay, how about this? Distribute, you get AI, not artificial intelligence, just AI, plus BI squared. Remember, I squared is -1, so this is going to be negative B plus AI. Beautiful. So now we're looking at the following. By the way, these two canceled out. I'm going to go ahead and erase this part. So this gave us A squared plus B squared minus 2 times the real part of this. Now, the question is, what is the real part of this? Can you tell me? Easy. That's negative B, right? So I'm supposed to multiply -2 by negative B, and that should give me a 3. Awesome. Wait a minute. Can I solve this equation? Well, let's take a look. Now, we have the following equation. Let's go ahead and take a look. We get A squared plus B squared plus 2B, or not 2B, equals 3. Sorry, I had to say that. Now, this equation has 2 unknowns, so I can't really solve it unless A and B are integers. Can they be integers? Probably, I don't know. And we are supposed to solve for all solutions like real numbers, right? Not just integer solutions. We have to check all possible solutions. So, completing the square came up again. Isn't that nice? Now, let's go ahead and add 1 to both sides. And this gives us A squared plus B plus 1 quantity squared equals 4. What does that remind you? Maybe it doesn't remind you anything. You know why? Because this is like a locus problem, and we'll talk about what that means later. But for locus problems like this one, where you have like 2 variables in the same equation, then you might switch from AB to XY. Why? I'll show you. So instead of using A plus BI, if you use X plus YI this time, sorry, A plus BI, no offense, we're going to use X plus YI this time, you're going to get a different equation. It's going to be very similar. Just replace A with X and B with Y. And guess what you're going to get? This is going to be the equation of a circle. Your job is to find the radius and the center, but locus problem is basically all these complex numbers that satisfy this particular equation. What was that equation? Absolute value of Z squared minus 2 times the real part of IZ equals 3. All these numbers are on this circle. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and don't forget to check out Cyber Math and A plus BI, and bye-bye.